Welcome to my page. Today we are going to look at cycle geometry or cycle theory. And so we'll look at the properties of a cycle. That is one of our theorem where we take our theory from. So let's go straight and talk about a cycle. A cycle is something like this. Don't mind my drawing. So a cycle has many parts: the center, radius. So first of all, let's talk of the chord of a cycle. A chord is a line joining two parts of the cycle, two sides of the cycle. Okay? It could be a diameter or ordinary chord. Okay? A chord, for example, joins A to B. This could be the center of the cycle. Let this one be the center of the cycle. All right? And so, let me draw another one and talk about it. This is a chord. Okay? Now, we have, this is major arc, minor arc, all right? We also have this as minor segment. Major segment. Okay, these are the things we're going to look at. But it is not our major concern, but we need to understand these parts of a cycle. An arc is a line that joins two edges of the cycle, while a segment is portion of the cycle. It's a portion of the cycle. It could be major, it could be minor, and so also the arc. So what is this theorem we are talking about? You can see here is boldly written that a straight line drawn from the center of a cycle to a chord divides the chord into two equal halves and also perpendicular at right angle to the chord. So what it means in its simplest form is mind you, let's say this is the center of the cycle. You already know what is a diameter. We have diameter, we have chord, we have arc, we have segment. These are parts of the cycle. A diameter is a straight line that divides the cycle into two equal halves. A chord is a line that joins two sides of the cycle, but not a diameter. An arc is a line that joins two edges of the cycle, and a segment is a portion of a cycle. Okay? And so this rule we are talking about, this is our cycle theorem 1. We have a line like this to a chord. Let's say this is the chord AB. The theorem is saying that a line from the center to the chord Let's say this is at C. Divide chord AB into two equal halves. Okay? Divide chord AB into two equal halves. For example, if we say AC, line AC is equals to line CB or BC, you can call it. Okay? Therefore, if you have here as X1 and X2, X1 is equals to X2. I don't want to go into the proving of the theorem that a line drawn from the center of a cycle to the chord divides it or bisect it and is perpendicular to the chord. Okay? But this is the simplest things I want to let you know. So this is all about the theory that a line from the center to the chord is at right angle. Here is 90, here is also 90. And also, it divides the chord into two equal halves. So you can say from here to here, a line from the center of a cycle to the side of the cycle is called what? The radius. This is radius. We call it radius. It's what? It's the radius of the cycle. So that ends the whole stuff. This is the theory. It's very simple. And just understand it as simple as this. That a line from the center of a circle to the chord divides chord AB into two equal halves and is at right angle to the chord, which I have shown here. And so let's take one example and we'll see. Let's take one example and see. You can see example 1. Let me write example 1 here. The radius of a cycle is 10 centimeter. Is 10 centimeter. Full stop. The length of a chord of a cycle is 16 centimeter. Full stop. Calculate the distance of the chord from the center. Center of the circle. The radius of a circle is 10 centimeter. The length of the chord of the circle is 16. Calculate the distance of the chord. Okay? So let's solve it. All we do is to draw the cycle and draw a chord. And say this is AB, as usual. So we say this is the center of the cycle. The length of the chord is what? 16. 16 centimeter. From here, you can see the length of the chord of the cycle is 16 centimeter. And the radius of the cycle is what? 10. So you draw a radius to it as what? You can draw any side. It's 10. Calculate the distance of the chord from the center. This is the distance of the chord to the center. Okay, and so it's D. Here is at 90. Okay, mind you, we have already stated in the theory that a line from the center to the chord divides the chord into two. So if you divide the chord into two, 16 divided by 2 is what? 8 centimeter, 8 centimeter. You can also take this side, any side you want, as what is okay. So you have seen it that we have a right angle inside the cycle. So we'll bring it out like this. One side, this is what? Your A. You can call this place, this is center of the cycle, as what? Your C. So this is C, and this is O as the center. Okay? We have 8 here, and we have 10 centimeter. What is our D? The distance from the chord to the center. Using normal mathematics, which is Pythagoras theory, using Pythagoras. Pythagoras theorem. Okay. We can now say it. AC square plus CO square is equals to AO square line. What I mean is that line AC square plus CO square is equals to AO line AO square. That is Pythagoras theory. The square of the side is of adjacent and opposite. The sum of the adjacent, the square of adjacent and opposite is equals to the square of hypotenuse. So we have 8 square plus D square equals 10 square. So which we have 64 plus D square is equals to 100. So let's find our D. We have D square is equals to 100 minus 64. Our D square is equals to 100 minus 64 is 36. So this D is equals to the square root of 36, which is 6. So the distance of the chord from the center to the chord is 6 centimeter. 6 centimeter. And that solves the whole issue. So it's very simple. Just note the rule that a line from the center to the chord divides the chord into two equal halves, and that is one is at right angle to the chord. So I believe this one example can give you the idea of what we're going to talk about. So in the subsequent video, I'll be solving so many examples on this chord theory one. And as you stay along, you will understand it more. Thanks and bye for now.